Hello, everybody. My name is Philip Bangerter, your moderator for the session. I'm originally a mineral processing engineer, but since 2004, I've been a sustainability specialist in the mining industry. I live and work in the southern outskirts of the city of Brisbane on the lands of the Bangerter people, traditional custodians of the lands and the waters around here. I take pleasure in acknowledging their traditional custodianship of the lands and the waters, and I pay my respects to ancestors and their descendants who continue cultural and spiritual connections to country, as well as making valuable contributions to wider society. I also declare my support for the voice to Parliament and of the Uluru Statement. And to any Australians watching and listening, it is but 1 week before the referendum, and a reminder that voting is compulsory. Welcome to you all for this exciting session of the LIAMforum. I'm glad to say this is my second LIAM, and I'm very pleased to be here. Liam Zisman perhaps typifies the young professional that the geosciences and indeed the mining industry should attract. He was passionate and caring, smart, and wanting to make a difference. And the assembled panel today wants to talk about that and talk about it in terms of challenges, but also the exciting work going on in tailings reuse. And I hope you'll enjoy the session. I'll be asking each of them to present a few slides in their area of expertise and current focus. And as we progress through each panelist, we would love it if you would drop a few questions in the Q&A or the chat facility, and I'll present those questions at the appropriate time to each one of them. So without any further delay, I'm going to ask Laurie to start the ball rolling. I'm going to do that by asking him to give us a sense of what tailings are for a start, just to set the scene. But Laurie, I do want you to open with why the heck did you choose the mining industry? It's not necessarily everybody's first thought. So as you know, my story was a little bit accidental, but what about you?
And thanks very much, Phil. And I'm joining today from Vancouver. It's the traditional and unceded territories of the Musqueam, Squamish and Tsleil-Waututh nations. And here in Canada, we've just recently celebrated National Truth and Reconciliation Day. And thanks also, Phil, for talking about the voice in Australia. I hope that referendum goes through. So in terms of me, and Phil, you've got some slides up, right? I don't know how that works.
Oh, no, you can share yours if you like, or I can do it, whichever you like.
I need to share mine. Sorry, We'll just the procedure, right? I just got to open them up. Yeah, just give me 2 secs, and I'll put that up on the screen. Hang on. Just give me a sec, Phil.
Sure.
I should have had them open and ready to go. But while I'm bringing up those slides, so my background, I'm a minerals processing engineer and also a sustainability professional. So I did an MBA focused on environmental engineering and sustainability about 15 years ago now. So I've been back to university a second time. Based in Vancouver, as I said, my accent sort of gives it away, though. I have spent most of my time in Australia, grew up in Australia, and came to North America about 15 years ago now, and have been living in Canada now for the last 12 years. Okay, so I'm going to just open these slides and then see if I can share my screen. Hang on. Forgive me with the technology for a minute here. Share my screen. Okay. Okay, and let's see if this works. Okay.
You got it. Just
that work okay?
Yeah, we've got your screen, but you'll need to blow it up to present.
Yeah, there we go. How's that?
Yeah, that's good.
All right. Okay, so this is me in 1992. This is a place called Mount Isa. Mount Isa is a pretty famous mining town in our outback Australia. So I've been in the mining industry now since the early 1990s. I chose that career really because I was always interested in engineering. I was going to be an engineer pretty much since I was, I think, 10 years old. I decided I was going to be an engineer. And process engineering sort of ended up being what excited me. So initially I was thinking probably chemical engineering, which is a more general form of process engineering. You can go into all sorts of industries, but When I was at university and we did a common year of first year engineering, I met a professor, famous professor in Australia, who Phil also knows. His name's Albin Lynch, and he was offering vacation work in mining towns in outback Australia. And so I took on that opportunity in 1990. I went to a place called Broken Hill and then later Mount Isa. That's a picture of me after a day in the concentrator. And I'd got a little bit dirty and I was pretty excited. We were playing with extraction of copper, and it was good stuff. And this is 30 years later, up in Red Chris in northern British Columbia at a copper gold mine. So still smiling. Those days are long and tough, but still smiling. So really, I got into engineering and into mining because the interest in going to different places, going to sort of remote and interesting places, working on interesting problems of how to extract minerals and metals. And really, I think my interest in waste management started also very early. I think went into mining recognizing that there were a lot of challenges there, but also that people like me might be able to help solve some of those problems. And really, what's driving me in the mining industry, why I've stayed in it for more than 30 years, is because I want to help find ways to mine responsibly and do less harm. Okay, so on the topic of tailings, what are they? Tailings are essentially the residue that's left behind after the processing of ores. They're typically a mixture of sandy or silty material, depends how fine you have to grind the material, and that's usually mixed with water. And we have processes like grinding and separation, etc. And then tailings typically come out of a pipe, like in this picture. This is in northwest Queensland. Typically, we will dewater those tailings in some particular way using things like this thickener that there's a picture there. And then the tailings are often stored in dams like the one you see in the bottom on the bottom right, which is a facility in eastern Canada. And the things that are important there, the characteristics of tailings are determined by the minerals that are present in the ore that's being processed, the choice of processing flow sheet and the processing conditions, interactions with water, and also the chemicals that we add in the extraction of metals and minerals, and how they're deposited and stored. And there's a lot of tailings produced every year in the world. So I'll just give an example there for copper. It's about 3 billion tonnes per year that are produced. So there's a lot of tailings. So it's a significant challenge for the industry. I think I put this slide here. We can't afford to get it wrong because in the past there have been some significant failures of tailings facilities. These have killed people, they've harmed the environment, they've caused great social, environmental and economic distress. And these incidents have happened in various places around the world. There's an example of a town that got inundated by tailings in South Africa, a incident in Brazil where a major tailings facility broke and went through a town and then contaminated a large river system. And this is the Mount Polly incident in British Columbia, where I live. So obviously these types of failures are unacceptable. There has been a lot of focus on tailings safety in recent years after some of these events. In particular, industry working with both NGOs, including the United Nations, and also investor groups. And that's led to the development of a standard called the Global Industry Standard on Tailings Management, the GISTM. And that's really to improve tailings practices and eliminate these types of failures. So I'm just going to lead in on the tailings challenge, and the panel will talk more in their areas of expertise there. But some thoughts and some questions that we really want to be asking ourselves as mining industry people, and potentially as yourselves getting into the mining industry. So how can we reduce tailings production and the footprint? So reduce the impact of tailings that are produced out of mining operations. Are there possibilities to reprocess or reuse tailings, for example, like in construction materials? You can see a picture here of some sand materials that have been extracted from tailings. There's various work going on in places like Brazil for that. Can we use the property of tailings to mitigate environmental problems? And some of our panelists will talk about that some more. How to progressively rehabilitate tailings and create useful landforms. An example here from North Queensland is tailings that have been covered with solar panels now generating electricity in Queensland. That's a beneficial use after the end of tailings facility life. And key message really here is that solving tailings challenges needs systems thinking. So we've got to think about how all the pieces of a mining operation, infrastructure, and a location fit together. And it needs smart people like you, and encourage you to think about how getting into the mining industry to work on problems like, for example, tailings challenges can help both meet the needs for society of minerals as well as creating less impact. Okay, that's it for me. So I'll stop my sharing. Thanks, Phil.
Thanks, Laurie. Thank you, Laurie. Believe it or not, we've got our first question, which I think I might just inject here, since you've raised those, and I think it came at just about the time you mentioned the copper and the production of
Yes.
copper tailings, and so I'll read it to you. Despite higher recycling rates for many metals, we're still faced with an energy transition needing mining and hence producing those tailings. So I guess copper is a very good example of that, with windmills and electric vehicles and so on. Need more and more. Question goes on, is it then just a question of what we do with them? Because we've historically left them static. So that's obviously somebody from the mining industries put that in there. Any response to that just before we move on? No?
Yeah, look, I think, it's really an all of the above thing. I think we want to find ways to make less tailings for sure. And there's different types of processing techniques that can do that. And I think some of our panelists will talk about some alternatives there that generate less tailings. Certainly, there's a possibility of using tailings in construction. We dig a lot of aggregates and sands and so forth for construction materials. Mine tailings have the potential to meet some of those needs. That's certainly an avenue. There are a lot of legacy sites, and so some of the issues with tailings is turning facilities into better landforms. But I think really we need to be looking at all of the above, and in doing so, thinking about how to reduce the potential bad impacts of tailings, especially around water, as we form these landforms or as we reprocess these materials for beneficial use. So hopefully that answers the question, Phil.
Yeah, I think so. And obviously there's rehabilitation, but I do like that picture of the solar panels. I can verify that we have lots of sunshine in Queensland, and
yes.
That's at least a very good use. I'm going to move it on and reduce the number of Australian accents in the conversation here. Zivi, perhaps you could unmute and give us your perspective. You're a young professional and obviously been in academia as well, but you've got a wonderful topic. I'm really interested to have this one here. So if you wouldn't mind taking over, that'd be great. Thank you.
Yeah, thanks, Phil. So my career story is a little shorter than Laurie's for sure, but I'll jump into my slides. So I'll start off with, I got my undergraduate degree at Trent University in Peterborough, Ontario in environmental geoscience. And I'm still there as a graduate student in the environmental life science program, where I'm specializing in carbon sequestration by mine waste, or those mine tailings that Laurie just talked about. So I'm so glad you set that up so nicely. So with the amount that we've produced over the years, there's a lot just sitting around. And so my thesis was mainly to focus on what we can do with that. But before I jump into that, I'll start at the beginning. I chose Trent because I was really interested in geology and especially environmental sustainability. And knowing that geology goes hand in hand with mining, there's a lot of conflict between those interests. So digging up those rocks, but also keeping the environment in its pristine condition that we have it in. So going to Trent, in around second year, I applied to a geoscience lab where their purpose for their research was to repurpose the mine waste so it could divert or remove CO2 from the atmosphere. And that was the perfect combination of geology and environmental sustainability that I was looking for. And so to jump into my two slides, I mainly look at the process, which is called enhanced rock weathering. But to understand enhanced rock weathering, we all need to recognize that rocks naturally break down, as we know, and silicate-containing rocks, so containing lots of silicon in there, they naturally remove CO2 at about 1 gigaton per year. Now, the amount that we're putting into the atmosphere each year, I think it's around it's 32 gigatons, I think, per year. Correct me if I'm wrong. But the amount that we're putting in and the way we're living isn't feasible just to rely on that natural process. So enhanced rock weathering is taking that naturally occurring process and accelerating the rate at which it removes CO2. The way we do that is taking those silicate-containing rocks, crushing them up into a fine powder. So we're increasing the amount of reactive surface area, and we're spreading it over land surfaces so that it can react with water, CO2, and its natural environment to increase the amount of CO2 it's removing. Now, of course, the smaller we crush it up, the faster it'll dissolve, but that itself requires quite a bit of CO2 outputs. The machinery that we use to crush up those rocks costs a lot of money, it takes a lot of time, and ultimately more CO2 that we're just going to have to take right back out again. The environmental impacts, of course, crushing the rock up, it's going to put a bunch of elements into the environment. We want to make sure that the rocks we're choosing don't put in arsenic or chromium or nickel into our water sources, for example. And in the enhanced rock weathering community, we typically tend to use basalt and commercially buy that to spread it over agricultural fields, for example. But in a nutshell, there's not enough rock to remove the amount of CO2 we want to, at least the amount of rock that we can commercially bring in, which is why universities like Trent or the University of Queensland and University of Alberta, we're all looking at mine waste and those fine processed tailings that have already been crushed up to the size we want them for spreading. And of course, you can't use all mine tailings. The picture of me there is actually from a historic gold mine, so we wouldn't use those tailings because there's lots of arsenic in there that needs to be remediated. So that is an example of a rock that we would not use for enhanced rock weathering. But there are plenty of other rocks like kimberlite, which is mined out for diamond mining, like the Gauchquay diamond mine up in the Northwest Territories. And so taking those tailings from settling ponds, we could potentially spread them over the mine site or degraded lands, or in some cases, agricultural fields to aid in that carbon sequestration acceleration. Now, there are plenty of active mines that are actively producing all of these tailings, but there are hundreds and hundreds of historic mines that are just sitting around with an untapped resource of potential enhanced rock weathering feedstocks. So that's the whole purpose of the Power Geolab, and what my thesis is all about is trying to find a way we can reuse this waste, this vast quantity of waste. And so it was a very quick talk, but I'd love to talk more if there's any questions. But this is a shameless plug for the lab I work in. If there's any students out there, master's, PhD, undergraduate, it's a great lab to work in. And I truly feel like I'm making a difference. If that's what you are aiming for with your career or in academia, this is a great lab and a great topic to dive into. Carbon sequestration is all the rage right now. So thank you very much.
Thanks, Zivi. In fact, I've intersected with this topic a little bit myself, a very little bit, I might add. So I'm glad that we get the opportunity to ask the questions. One of the ones that has dropped into the Q&A is about acceptance, public acceptance. So, of course, I'm going to paraphrase this question. The little bit of work I've done in this area, when we talk about agricultural land, of course, that's potentially the food chain. And so you mentioned arsenic and avoiding those sorts of things. So what is the public acceptance like, do you think, for taking what in many jurisdictions would be classed as an industrial waste? So I think the classification of the industrial waste is also important, if I've got that right as well. So have you got a sense of what the public acceptance is like?
Yeah, I don't have any specific numbers to touch on that, but I know it is increasing in acceptance for sure. The basalt is already a widely accepted agricultural amendment. Wolstenite, which is a mineral, not a rock, but there are wolstenite mines in Ontario, and that's used as a amendment. I think wool grow is the commercial name for some of these. Kimberlite, the rock I use, hasn't entered that stream yet, but we are increasing its acceptance for sure, because there are those nutritious properties releasing potassium and phosphorus into those soils. So we definitely have a case to make to gain its acceptance for sure.
Precisely, I just look back to some work I did with the alumina industry. So the bauxite residues that get produced. In fact, that is the biggest mining waste in the world, and there's little bits of work going on around that, looking at carbonation for neutralization of those residues as well, but also their use on agricultural land has also been a topic over the last 20 years. I'm quite aware of those. I think the public acceptance 20 years ago when this first started was okay for a start, but then there were some issues and so on. So that's a very good question asked there about. But anybody else got a response to the public acceptance at all?
Yeah, Phil, there has been a history of using mine tailings as agricultural ameliorants in a few places. There's a mine in Brazil that does it, and a mine in Tennessee that I'm aware of, and also one in Canada, I think, that's done quite a bit of research. And it's really about understanding the nature of the rocks that are in the ore and the characteristics there. It does need to be closely monitored, but it's really about quality control, and I think and education and so forth. And certainly some ore types are not going to be suitable because of the risks of certain contaminants getting into water supply, etc. So I think if the industry considers possible end users, does its appropriate research, if there's some independent verification and so forth and quality control, I think it's something that can be done.
I just think it's a neat intersection of two industries that can, as soon as you get two disparate things coming together, you often get great innovations that are not immediately obvious to everybody.
So,
or I'll
Philip,
keep my eye. Yes.
I have a comment on that.
Vikram.
So Zivi is obviously doing some very interesting academic research, and so one of the things that has changed drastically over the last decade or so is the intersection of good scientific fundamental research with also research on social acceptance and getting public buy-in into the research. So if you look at any major grant that is awarded in the environmental sciences, geosciences, you always have to have that aspect where you're understanding what's the impact both on the environment, on the people, on the economy, and this is now central in all of these grant applications. And so the funny analogy I use is, many of the audience members, I don't know what the age demographic is, but once upon a time, cell phones, there was always this perception that you could get brain cancer if you keep using your cell phones. And today, you can't imagine an individual, this is the universal sign of, the person is sane and is using a cell phone. So it comes with education. It requires early engagement with individuals who are studying regulation, with policy, with stakeholder engagement. And as Laurie mentioned very appropriately, education and dissemination of that knowledge to the public. That is going to be essential in these technologies getting to the market and then having the maximum impact.
Yeah, and if there's a technical benefit to the growth of foodstuffs or clothing or whatever the fiber might be, I think there's a really good case. There's lots of agricultural ground, and we've got lots of tailings, so there's a synergy there. I'm going to come back to the topic of whether the tailings are close to something useful or a long way away, but I'll certainly come back to that topic. I am going to ask Abe to perhaps jump in now and let us see his slides and his topic. Thanks, Abe.
Great, thank you. Excellent presentations up to now. I'm really honored to be on this panel today. with such amazing colleagues. So my name is Abe Jalbout and currently serve as CEO of Auxilium. As was already mentioned in the previous talks, mine tailings are the waste that's left over after all economic value is extracted. Obviously, there's both a solid and liquid component, which become important to identify solutions to deal with. Auxilium does repurpose 100% of the input tailings feed, producing different products of value. I'll go through some of those different products and also some statistics around tailings. So the mine life, in traditional sense, is over when the mineral resource of interest is depleted. However, mine lives on after closure, typically as a financial liability to the owner. So if a site could generate carbon negative building materials while producing critical materials, it could essentially extend the life of mine. So beyond life of mine planning. Currently, evaluations are made after tailings have been transported and stored at cost. But if we can transform these tailings into secondary materials, the economics can improve in addition to minimizing environmental liabilities. Strategies that involve tailings repurposing are absolutely a way to offset tailings storage facilities altogether. In terms of the mining industry, I believe it's really embracing emerging technologies that can increase productivity, reduce liability, and also positively contribute to the overall financial viability of new and existing mining projects. Tailings valorization essentially refers to reframing mine waste as something that has value. The idea is that we can take advantage of what has traditionally been seen as a liability and turn it into useful products such as construction materials and others. This includes reprocessing of tailings to recover any residual metals, minerals, and of course reagents that are needed not just for the ongoing operation, but also to repurpose more of these tailings. The concept of tailings valorization is in its early stages, and it's something where talented scientists and engineers have identified numerous processes that go beyond metal recovery. Materials such as aggregate, construction materials, industrial minerals can all be recovered and used for things such as soil amendments, land reclamation, and others. To combat the risk associated with tailings, Auxilium has developed Entail. So Entail is a regenerative solution that generates important products from tailings. Globally, over 8 billion tons of tailings are produced, and over 280 billion tons of tailings exist from past mining activities. In terms of the breakdown, as was mentioned in one of the previous talks, the largest contributor to tailings is essentially the copper industry, which accounts for roughly half of that. So decreasing ore grades combined to net zero targets obviously will not only elevate these numbers to come, but also require that steps be taken to mitigate these. In terms of some statistics, if we were able to process legacy tailings, or in other words, tailings that are left over from past mining activities, we can provide enough metals for the next 70 years of current production levels. Processing fresh tailings or fresh mill tailings that are generated can increase metal supply chain by over 30% at current levels of production, while providing 3% more rare earth elements and reducing global emissions by over 2%. The world needs up to 3 times more copper by 2050, which translates to roughly 50 million tons of copper, which Entail will contribute to 3% of this target while displacing over 1 gigaton of CO2 and eliminating over 1 billion tons of tailings over the next decade. There are several also other important decarbonization benefits to repurposing tailings. In some cases, processing up to 20% of fresh tailings is enough for a mine site to achieve carbon neutrality. Other important benefits include beyond life of mine planning, reducing the burden of the tailings storage facility, waste reduction, and of course, access to new revenue streams. Delivering low-cost carbon negative value-added products is something that the public will seek out eventually. Carbon accounting will help us to visualize and understand energy that is invested into products, allowing us to accurately assess what can be done with everything a mine generates. There are enough significant tailings deposits around the globe to supply new critical materials, including green construction materials, to every geographical location on Earth. Just to close out, I appreciate the opportunity to sit on this panel. I'll just close out by saying that we don't always know what our career path we will take. Personally, I started my career as a professor in chemical physics, then as an entrepreneur building a commodities trading platform, finally progressing to a career in mining. We need all skill sets and collaboration to tackle massively important issues such as climate change. We need to think differently. Solving problems in the resource industry is not only a career choice, more of a life's mission that's fueled by the passion to change the world, and working together we can. If anyone's interested in reaching out or has any further questions or comments, please feel free to do so. Thank you.
Yeah, well said. It's terrific, and I have a question myself. Actually, Laurie will know of New Century, which is reprocessing tailings, and it's in a remote location. So the notion of valorization is interesting to them. So they could certainly are or have been valorizing via creating metal, creating product that was left behind previously because it's a legacy, decades of production with decades old technology, and now with a little bit of help, a little bit of repurposing, they can reprocess those tailings, and indeed those tailings then obviously create their own tailings from being a waste that's had metals taken out of it. They're putting those in an old mining pit, which is an even better place to put them than they originally were. But that is in a remote location. So the actual use of the remaining tailings after taking metals out is an ongoing thing. It's too far away from potential markets in the middle of Queensland, where the population is very sparse. So any comments about what I would call proximity? So some tailings are proximate to potential markets, and others are remote, and so there's a financial burden to so how much of the carbon story wraps into improving those economics?
Well, the economics, it lies in to be able to produce value-added products beyond just construction aggregates and things like cement.
Yeah, yes.
As a company, we have identified value-added products that roughly bring between 10 and 20 times the traditional, cementitious material. So in that case, it does make sense to export these. Obviously, the carbon, accounting aspect is important in terms of more of environmental aspect. At this point, it's still in its early stages in terms of how companies can actually monetize that, but absolutely a definite benefit.
Yeah, I think part of your thesis was that we haven't solved this completely yet, and so there's a lot of years ahead of us in trying to make this a better story. And so a valorization is one of those, and wrapping the carbon story around it is an addition. Yeah, Laurie, any additional from you?
I think the more that we can identify potential products that come out of tailings, the more we can open our minds to how they could be used and how to get them to potential markets. I think certainly, transport is a challenge in certain places, but in some cases, if you're close to railways or close to the ocean, it can be easier than you think and cheaper than you think to transport things quite a long way. So I think the first thing is exactly what Abe's doing, which is to identify potential beneficial use and to make these materials attractive, because right now people are moving, virgin extracted materials, from other places a long distance for various purposes. And there's no reason to think that we can't do something different with tailings and often make it worthwhile. That would be my take.
So to my and I could spread the argument a little bit about the difference between legacy tailings and currently arising tailings. So my further question to the panel is, how is it taken up in the original planning for a current project? Let's say we're not yet building the mine, we're doing it. The value of tailings is still rarely understood post-mine use. So it's becoming a topic, or is a topic in certain projects that we intersect with, but not all projects. So any Abe, perhaps you have a view on that, currently arising tailings, or has most of your work been around legacy?
Yeah, we do work with both legacy and fresh tailings. And really what we want to move forward, I think one of our our primary goals or mandates is to really start with what we call beyond life of mine planning. So at day zero, when we build these mine plans, we can actually integrate these new solutions into how people think about the future of their current operation, right? Whether it be existing or in the pipeline, right, for new projects.
Well, I could just imagine, Zivi's topic around an agricultural post-use for certain tailings, kimberlites. This is my go-to in my memory, and that should be part of the planning, perhaps, rather than the traditional things. So very good. Vikram, can we ask you to perhaps take the screen and give us some more talking points? Just a reminder to listeners, very happy to take some more questions. I've had a couple and love some more. Vikram, you're on mute.
All right, fantastic. No, I didn't begin speaking, so I get some brownie points there. So, well, pleasure to meet everybody, and well, it's been fascinating to be a part of this panel. It's a great honor to participate in this forum. So, like Laurie, I too am joining you from Vancouver, and I reside on the traditional and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh Nation. So, I would like to start today's, at least my contributions to this panel, by providing you 3 statistics. So one statistic is, if you often poll people around the world, which is the largest source of copper on the planet, everybody universally will tell you it's the nation of Chile. So globally, global reserves are about 880 million tons of copper. The nation of Chile is about 25% of that, 220 million tons. There is as much copper present in waste streams as there is in the entire nation of Chile. So when people talk about tailings, as the traditional definition is, once the useful part of the ore body has been taken out, what's left over is tailings, is actually incorrect. It's because you could argue that there's just as much value in what's left behind as what is taken out. So looking at tailings, revisiting our relationship with tailings is going to be critical. And also, if you look at another very important statistic, is the cost to produce copper. So if you look at a new mine today, it is averaged that to produce a ton of copper, the levelized CapEx and OpEx is going to be about $44,000 a ton. And that's clearly telling you that as we move towards electrification and net zero, we simply cannot sustain that vision in the manner in which we are currently mining. And when I say that, especially how we leave behind tailings, which is so useful. So echoing what Abe said, valorization of tailings, and especially my area of focus is looking at the liquid part of it, mine impacted water, acid runoffs, the water that sits in the tailings. We're talking of well over 220 trillion liters of water. And many times these waters get concentrated with useful metals. And so what TERSA, and I am the CEO of TERSA, which is a technology company that is developing processes to produce essential metals that we need for electrification from these very waste sources. And the manner in which we do, my area of focus, I am also an academic at the University of British Columbia. It is to use biotechnology to solve that problem. And we use biotechnology that allows us to have a lower carbon footprint. And more importantly, we address the issue of water security. That is how we wrap all of these objectives together. So the process that we have developed, and I'm an academic, so at danger of going into a 2-hour lecture, I won't go into the specifics. But since it's biology, we are able to address that wastewater, extract all of the useful metals. It is done in a carbon neutral manner, and that translates to significant carbon abatement potential for mines. And then more importantly, we're producing 2 very important products, clean water and a lot of metals. So very similar in philosophy to what Abe is trying to do. And if you actually look at, and to elaborate some of those statistics, you're looking at copper. We've also had tremendous successes with gold, with lithium, and we've also been able to use this process to degrade a lot of organic compounds that reside in these waters as well. So looking at metals and water for the next net zero transition that we are facing as a society. Very briefly, the biotechnology, it is building off of a tremendous advancement in our ability to understand biology, but also engineer and control biology. And we use synthetic biology. It is the tool of choice, and it's something that we have used to engineer these microorganisms. And then there is, as the joke says, Murphy's law usually says, biology is only defined as something that stinks. So instead of just remaining in the biology world, we actually take the biology and we try to industrialize it. So there has been a lot of know-how that we have developed in terms of engineering these processes. Is because ultimately it has to succeed at scales. It has to make sense with the existing logistics and supply chains from mines, and it needs to integrate as seamlessly onto the site of an existing mine or a tailing storage facility, for instance. So just as a comparator, and I will wrap up in the next 30 seconds, you compare it to existing solutions. Existing solutions, one of the most dominant ways to treat especially acidic water is to use lime neutralization. We are completely doing away with that. Is because we now have the toolkit to think beyond lime and to actually think of not having carbon intensive processes to manage and handle that water. And also, we are not converting liquid waste into solid waste. We're actually taking liquid waste and converting it to useful metals and clean water. And that is a shift in the thinking. And at the end of the day, decarbonization, improving the economics of mining, improving the productivity for mines, and significantly reducing the liabilities. So revisioning tailings, not as a liability, but as an asset. And that is what cutting edge technology and innovation allows us to do. And to very briefly touch upon this, and this is because we were asked to provide maybe some advice to future professionals. There is no greater challenge facing civilization than the transition to net zero. We know what the cost of it is going to be if we're unsuccessful in that transition. And unfortunately, you only have two options. You either live with that uncomfortable reality and things just proceed as they are, or you actually take a look at mining, look at these fundamental processes that sustain civilization and bring innovation to the table. So to me, mining, manufacturing, these are some of the most innovative sectors. They're going to see a renaissance in the years ahead, and we need as many bright individuals pursuing these disciplines as we can, because civilization depends on this. And this is going to require engineers, scientists, geoscientists, environmental professionals, but then it is also going to require people who understand policy regulation. And then, of course, people who know how to run businesses. As Abe and me are testament, you're seeing a lot more entrepreneurs in this world than you did before. And so with that, I will stop. Thank you for the opportunity. And it's been a real honor to share the stage with some tremendous individuals. Thank you.
Thank you, Vikram. I just love it when biology comes knocking on the door of the mining industry. I've got to say that it comes every now and then, and I absolutely delighted to hear about some biological approaches to these sorts of things. As I think I mentioned a few minutes ago, when you get more than one industry together, more than one discipline together, you actually find innovative solutions that you wouldn't otherwise have found. And I've got to say that treatment with lime just gives you a nice sludge to deal with afterwards, and sure, you got the metals taken care of, but it produces its own problems. So go biology. And in fact, having academic on the panel and a young professional in academia, there is a question. I suspect it's for you, Zivi. So I'll ask you. How does I'm going to paraphrase again, but how does academia prepare you for the transition into operations or into industry? I guess is that's so many PhD candidates that have asked me that question. So I'm going to ask you, how are you? How do you feel about it?
Yeah, well, I'm actively trying to make that. So I'm in that process right now. So I know I attended CIM earlier this year in so the Canadian Institute of Mining conference that was in Montreal, and even just how many months ago? 6 months ago, I was there and I was talking to Agnico, and they were like, "Well, what job do you want to get into?" And I was like, "Well, I don't even know what's out there." So I had no idea because I had been so far into academia. I just wasn't sure of the opportunities in the industry. But to touch on the skills that are transferable, I've done so much sampling and technical writing that for sure what you learn in academia is absolutely transferable to the industry, and I have no doubt about that. It's just trying to figure out what's out there, So forums like this is a huge help. I've attended so many sessions, and really this is a great platform for that. So.
Super. And speaking of Agnico Eagle, very, very fantastic people. Laurie and I have been just touched with them, and in the last 48 hours, actually, they've sponsored something that we're very passionate about. And so now, if you need a connection in Agnico Eagle, if they haven't already offered you a job, then just drop me a line. I've got one for you. Mohammed, if you are online on this forum, please reach out to Zivi.
I can add to that because
please, Vikram, I was going to throw to you next year.
I have had the pleasure of interacting with a lot of superlative talented people such as Zivi, at UBC, and that's actually one of my number one reasons to remain in academia, is that you are surrounded by extremely passionate, intelligent individuals who have new ideas. They bring new ideas to the table. They're not exhausted skeptics such as the old professors like me. But maybe perhaps what I could tell you from my own mistakes and misadventures in life, when you go through any specialization, be it an engineering undergraduate degree or even when you do a PhD, you develop there's two mistakes that almost everybody makes. One is that you develop a false sense of ego, that you are the expert in that particular topic. And then you believe that since you've gone through that process, you are not just an expert in that topic, but that is the only topic that you are allowed to work in. And so most people that come out from grad school, they may be working on, I'm just making this example up, the hydrodynamics of how liquid is flowing inside one of these aquifers, for example. And you believe that is the only tool or the only problem that you are going to be entitled to get a job with. But instead, when you're going out for jobs, you have to actually think about not about the world as a collection of companies that do specific things that you do, but it's where you can apply your skills. So going back to what Zivi said is thinking about problems and how you can bring new thinking to solving those problems. Is because there's plenty of problems out there. And, if a young professional were to ever come to me and say, I have some ideas and this is how I would like to go about it, that is a much more interesting conversation and a much more valuable colleague to have than somebody who comes and says, I know I'm going to be operating this system, I know this particular software, and I'm going to solve this equation for you. Because that's where the multidisciplinarity actually cannot come into the picture, is because you're coming in with a very set idea and a set concept. So think broadly, try to think about problems and where you can apply your skills. It is very rare for somebody to remain a professional in the degree that they pursued. You constantly evolve. You constantly get exposed to different aspects of the industry. And that's how you become valuable, and you make yourself valuable and a part of these high-performing teams.
Fantastic thoughts, Vikram. And sadly, we appear to be at the end of our time for now. So we will take care of any other questions that occur to anybody post Liam. But to wrap up, I'd like to thank my four panelists, Laurie, Zivi, Abe, and Vikram, and of course the attendees for their questions and their attention. I would close perhaps with one final observation. A career in geosciences is highly varied. as Vikram said. Specialized if you want it, broader if you prefer. It could be scientific, mathematical, technological, entrepreneurial, environmental, social, or indeed a combination of these. It can be methodical or ambiguous or exciting, but no matter which flavor you would like, it always matters. So thanks once again, and goodbye for now from this session. Thank you.